Hello folks, we come to the part 9 video of the exercise, miscellaneous exercise of chapter 10, and this should be our last video. We are taking now the 23rd problem, which says that you are dropping two perpendiculars from first from point root of a squared minus b squared comma 0 and another perpendicular from the point minus root of a squared minus b squared comma 0 to the line x by a cos theta plus y by b sin theta minus 1 equal to 0. You have to find out what is the product of these perpendiculars. So right away we can start because things are defined and very clear, and we know the length of the perpendicular by formula ax1 plus by1 plus c by root of a squared plus b squared. So let's see right away. Let a, b, c points and line L be as shown in the figure. Right. Now we can take therefore distance AB. We can just brush up by formula ax1 plus by1 plus c by root of a squared plus b squared. So let's have it. ax1, so cos theta by a into root of a squared minus b squared, sin theta by b into 0 minus 1 by root of cos squared theta a squared plus sin squared theta b squared. Then and the distance BC is by same way. Let's take cos theta into a minus root of a squared minus b squared, sin theta by b 0 minus 1 by root of cos squared theta by a squared plus sin squared theta by b squared. Now therefore its product. Let's for now take its positive values. So it's going to be cos theta by a root of a squared minus b squared minus 1, this is of course 0, and first bracket, second bracket, cos theta by a minus root of a squared minus b squared minus 1 by root of cos squared theta by a squared plus sin squared theta by b squared, cos squared theta by a squared plus sin squared theta by b squared. We'll come to, let's solve this. When we open up, this will become minus cos squared theta by a squared into a squared minus b squared. Just check. Cos into cos and minus is there, cos squared, a into a squared, root into root, just a squared minus b squared, and then we will have minus into minus plus 1. It's of the type a minus b into a plus b. So root into root will become just the term. So cos squared theta by a squared plus sin squared theta by b squared. Root a into root a is a. That's how root same root into root will be just that number without the root. Okay, it calls for a lot of equalization and all that. Now here there is into a squared into a squared. Here it is into b squared into b squared into a squared into a squared. Then only we can have it like solved. Minus cos squared theta times a squared minus b squared plus a squared whole by a squared by b squared cos squared theta plus a squared sin squared theta by a squared b squared. We have learnt that this and this can cut each other. Now what happens when we open this bracket? Minus cos squared theta a squared plus b squared cos squared theta plus a squared by b squared cos squared theta plus a squared sin squared theta by b squared. So see, divided by something means multiplication by the reciprocal. So b squared can come here. Right, this is multiplied by the reciprocal, so b squared is coming in the numerator. Let's club these two terms together. So you have b squared times a squared into 1 minus cos squared theta. Just check, we have clubbed these two together, plus b squared cos squared theta by a squared sine squared theta plus b squared cos squared theta. 1 minus cos squared theta we all know is sine squared theta. So it is like writing a squared sine squared theta plus b squared cos squared theta by a squared sine squared theta plus b squared cos squared theta. We can have them cut. Answer b squared. So we are getting the 24th question. The answer comes up as b squared. That's what they've asked us. I think that's what they've asked us. Show that it is b squared. Yes, that's about it. Now problem number 24 is a very beautiful problem. It's a beautiful application of all the straight line concept that we have studied till now. It says that there is a person who is coming and standing at the junction between this line A, it's a road L and road M. So since the road M and road L are meeting, that point of meeting of two roads we call it as a junction. So this point A is a junction. This man is standing at the junction. Now this man has to go to another road, road N, whose equation, they all have the equations. You have to find out that which is that equation which should take him the least time. Now we should know that a perpendicular distance is going to be the shortest, and that is why that is going to be taking him the least time. So it's enough if we find this perpendicular, the equation of this perpendicular AB, we will get to know that that is the shortest route by which that man can travel. So that's our course of action. So let's proceed. Get the point A first, then get the equation of this perpendicular. That's okay. Point A you can get by solving these two. Then AB you can get the slope because of this, and because you know the point A you will get the equation also. So it's only a matter of applying things. So let lines L, M, N points be as shown. Lines L and M, routes meet at the point or junction A, and for reaching line N, AB is the shortest route. That's how we explain. Now we'll solve. Okay, solving equations of line L, M. That is 2x minus 3y equal to minus 4, 3x plus 4y equal to 5. So we do that bit of thing, this multiplied by 3, this multiplied by also this can become 6x minus 9y equal to minus 12, 6x plus 8y equal to 10, and then we can subtract. So minus 17y minus 22, y is 22 by minus 22 by, sorry, plus 22 by 17. Get the y value. Now take the x value. 2x seven fours are 20 minus 68. Therefore, point A is the junction. Yeah. Now we have to find out the equation of AB. So for the equation of the AB, already you have got the point A. Now it's enough if you get the slope. So slope and slope of line N minus A by B, minus 6 by minus 7, 6 by 7. Since AB is perpendicular to line N, therefore slope of AB. Directly you can get B by A or minus 1 by 6 by 7, minus 7 by 6, or you can get B by A also. Yes, F equation of AB, we have all the prerequisites. Y minus Y1 is equal to M times X minus X1. Okay, let's solve this first. Into 17, into 17. So 17y minus 22 whole by 17 is equal to minus 7 by 6 into 17, x whole by 17 cancel. Take 6. Yes, let's solve. 6 7s are 42, 102y minus 6 2s are 12, 132. 7 7s are 49, 119 minus 7. Everything on one side. 119x plus 102y plus 7. So it's like how much? If you subtract 125 equal to 0 is the equation of AB, the shortest route. So that's all about the miscellaneous exercise chapter 10. We finally finished the miscellaneous exercise. In the next video, we come with a new chapter, chapter 11. Thank you.